So yeah, hi guys, this is the session 3 that we are currently doing. This will be session 3 on your polynomials chapter. See, we have already completed our session 1 in which we had understood the basic concepts of a polynomial, and yesterday we had a session 2 in which we had discussed division of polynomials, we had discussed remainder theorems, and we had discussed our factor theorem also, right? A portion of factor theorem. I won't be telling you that we have discussed entire factor theorem because that was the topic that we are going to discuss today. In our last session, in a session that was yesterday, I had told you that during the end of our video, the method that we were going to attempt in a factor theorem that was quite lengthy. So I had told you that I will be picking up that today. So this is it. I will be picking that method now, and then we are going to shift towards a factorization of polynomials. See, I am using the term factor theorem and I am using the factorization of polynomials. So remember, when I say factorization, I mean we will be using our various identities in order to solve the given algebraic expressions, and then we are going to understand how we are going to come back to our initial state. That means we are going to factorize using identities also. So factor theorem will be giving you factors, but that will be a different scenario. While we are using factorization or factorization of our polynomials, we will be using identities, we will be using middle term splittings, we will be using our completing squares also. If you guys remember, completing square is also a part of your 8th mathematical portion. If you guys follow your RD Sharma's also, so you guys should be having that portion in your 8th also. But if you don't follow your RD Sharma's or any other reference book, if you only follow your NCRTs, then you guys should be familiar with your factorization or middle term splitting method, right? So I will be explaining each and everything for you. Don't worry if you don't remember anything from those. I will be explaining each and everything with today's session. And remember, this is the last session of our chapter 2 because our chapter 2 is not quite lengthy. It is very short as compared to our other chapters that we are going to focus on in near future. So remember, this is an easy chapter. So it will most probably be ending with this session only. So I hope this will be ending here. So I will be doing what? I will be having a slide now that will be revision of whatever we have done up till now. So let's just jump to it. And remember, you have to keep your pens and notebooks with you because you have to make proper notes and you have to attempt sums while you have understood the basic concept. Right? So with that being said, let's start with the revision portion. So till here we had understood what were polynomials, right? You guys had understood that any algebraic expression, it could be termed as your polynomial. It could have any power. It could have any number of terms in it. If I had only 2 terms, let's say x plus 1, that was what? That was my binomial, right? If I had only 1 term like my 2 of x, that was what? That was my monomial, right? If I had only a 0, that was what? That was my 0 polynomial, right? You guys remember each and everything from our last session, right? So that was the 0 polynomial. And if we had only constant values like 2, 3, 4, 5 and anything like that, those were what? Those were your constant polynomials, right? And when we had more than 2 terms, let's say we had 3 terms like 2x plus y plus 1, that was what? That was trinomial, right? You guys remember each and everything that we had done there, right? So these were the cases that we had discussed earlier, and we had also understood the concept of a division of polynomials, right? So I will be explaining that, and before that, let's just see. We also had these, right? On the basis of the degrees, we had understood the basic terms there. We had understood when the degree was only 1, it was what? It was linear polynomial. When the degree was 2, it was quadratic polynomial. When the degree was 3, it was cubic polynomial. When the degree was 4, it was what? Biquadratic, right? You guys remember that. So these were the forms of polynomials on the basis of their degrees. These were the forms of polynomials on the basis of their terms. So we had these 2 conditions and we had characterized our given statement or algebraic expression into its respective polynomial form, right? So that was what we had done in a session 1. We had understood that there, and we had also understood the value putting method, right? We had our p of x, like let's say it was 2x plus 1, and we had the value of x, let's say it was 3. So we had to calculate p of 3. That means we had to replace x with 3 in our p of x. So that means we could have solved that one also. We could have found out the values there. So that was what? That was the method, the value putting case, right? Then in our second session, we came to the concept of division, right? We understood division, and for that case, we had what? We had a p of x, which was what? Which was actually my dividend, right? Then we had our g of x, which was what? My divisor. right? Then we had a q of x, which was what? Our quotient. And lastly, we had r of x, which was what? Our remainder, right? You guys remember those? So these were the terms that were related to the division of polynomials. And once we had divided our p of x, that means our dividend with our divisor, that means d of x, we used to have this, our q of x, we had this one, and we had some remainder r of x. And you guys already remember your check formula. So p of x technically was what? It was g of x into q of x and some remainder r of x, right? We had something like this. So that was the whole point here. So I hope you guys remember this, right? So I will be doing what? I will be just quickly solving a sum for you so that you guys recall each and everything related to your division. Then I'll explain the remainder theorem for once, and then I will come back to our main topic, which is factor theorem for this matter. So division, let's say I had p of x, which was x cube plus x square plus x plus 1, and I had my g of x, which was, let's say, x plus 1 in this case, right? So we had to do what? We had to divide up p of x with g of x. So we used to do what? We just put our p of x here, that means x cube plus x square plus x plus 1. We had divided this with what? Our x plus 1. You guys should be recalling this from your class 8 also. If you have skipped your earlier class, that means session 2, you should be recalling this one from your class 8 as well, because you have understood it there also, and I have explained it on earlier session also. So don't worry, if you can't remember, just look at here. So in this method, we did what? We just compared our first terms. That means I will be comparing my x cube with this x. So I had x cube, I had an x, divide both of them, you will be getting an x square. So I needed to multiply my x plus 1 with an x square, and I will be getting what? X square into x, that will be x cube. X square into 1, that will be x square, right? Or you can do what? You have to divide them, right? So you guys remember, if you just normally divide any two values, let's say if you divide 12 with 2, you guys always look for what? Firstly you compare these two, then you see 1 is less than 2, so you will be observing this as 12. So you will be thinking of a number which is a multiple of 2. It is either a 12 or less than 12. Now same here, I can see my x cube, it is greater than x square, sorry, greater than x. So I will be thinking of a a multiple of my x, so that after multiplying that value with x, I will be having either an x cube or less than x cube. But in our polynomial case, we always observe that we need to have the same polynomial or same variable there. So I will be having the same variable x cube by multiplying my x with what? By multiplying my x with my x square, right? So once I've multiplied my x with x square, I will be having x cube. Then I will be multiplying my 1 with again x square, because this whole bracket will be multiplied with a quotient, so that will be positive x square. Now we did what? We just observed our terms on the lowest part here. I will be doing what? Observing their signs here. It is positive, so its opposite side will be negative. It is positive, opposite sign will be negative. These signs will be removed. Then I have to do what? I have to just normally add or subtract them. I can see this is negative now and this is positive. Positive and negative both will cancel out. Positive and negative both will cancel out. So both of these two terms cancelled out, and they gave me a 0, right? Then I will be doing what? I will be putting this down and having it here, x plus 1 now. I can see I have x plus 1 here, I have x plus 1 here. So that means I just have to multiply it with what? Just 1. If I multiply this with 1, I will be having what? X plus 1. Again opposite signs, negative and negative, both of them will cancel out. My remainder is what? This is the final answer, which is my r of x. This is what? This is my q of x. This was my p of x, and that was my g of x. So this is how you are going to perform division once you have been given that you actually have to perform division. But in our case, till we have to only find out remainder, we don't have to actually perform division there. But when we have been given a cubic polynomial, or let's say more than that one, that means a biquadratic polynomial, then we have to perform what? Then we have to perform a remainder theorem. We have to perform division. We have to even factorize our quotient later on. So that is what we are going to study today. I am going to tell you each and everything today, but don't worry. But as long as you just have to only find out the remainder, always remember, if you have to find out remainder, you don't have to go for entire division. You can do what? You can just use a remainder theorem. And what is that? I'm going to revise it again for you guys. So see, what is a remainder theorem? So remainder theorem states that you will be having any polynomial p of x, and in our case, let's say it is x cube plus x square plus x plus 1, our previous polynomial, our previous dividend. Let's say this is my dividend. Okay, there will be a divisor g of x, let's say it is x plus 1 from our previous case. We have to do what? We have to divide p of x with g of x, and we only have to find out r of x. Now, remainder theorem states that you have to do what? You have to just put your g of x against what? You guys remember this? Against 0, right? So, x plus 1 will be put against 0. X will be what? It will be minus 1. Now, we have to do what? We have to replace this x in our p of x. That means the method that we had discussed in our exercise 2.2. So, we will be doing what? Replacing this x here. So, I will be having p of minus 1. So, if I solve this, I will be having what? Minus 1 cube. Wherever you have x, just replace that value with your minus 1. So, minus 1 cube, minus 1 square, minus 1 and a 1. So, guys, see, cube of minus 1 will be minus 1. Square of minus 1 will be positive 1. Positive and negative, minus 1 and a positive 1. So, you guys see, negative, positive, negative, positive. Everything cancels out. And the remainder is what? It is 0. And you guys already remember, we had performed a long division also. And we had got the remainder, which was 0 there as well. So, you guys see, remainder theorem gives us exactly the remainder. But the steps that we have to follow, those are what? Those are simply this. You have to pick your divisor, put it against 0, get that value of x, replace that value in your dividend, that means your p of x. Whatever you get, the constant value that you get, or any variable for that matter. Let's say if you had something like this, if you had x plus a which was put against 0, then you will be having x which will be minus a. So your entire answer will be in the form of a. So don't worry, whatever you have, the finite value after substitution of your any variable, that means your x or your y, if you have substituted that variable for any other value, your entire equation will be converted into that value. So if you get your constant value there, that constant value will be what? That constant value will be your remainder. And if you get your answer in the term of any other variable, let's say in our case a, then it would be what? It would still be your remainder. So always remember, remainder theorem will be giving you directly the remainder. So that is the whole point here. I hope you don't have any doubt in remainder theorem. And in factor theorem was what? It was generally this one. While we had observed in others case, you guys see, we had observed a remainder theorem and we had found out that our remainder was 0. So whenever after applying the remainder theorem, you have ended up with a 0, that means you did not have any remainder, or you can say that your remainder was 0, then you would be saying that your p of x has a factor which is p of x. Like if you just divide 12 with 2, you will be having what? You will be having a 6 and you will not be having any remainder, will you? So you will not be having any remainder. So you can say 12 has a factor which is what? It is 2. And 12 has more than one factor. It has a factor which is 1, which is 2, which is 3, which is 4 and which is 6, and ultimately 12 itself. So you guys see, factors are what? Factors are those values. If you divide your dividend with the divisor and you end up getting remainder 0, that means that is a factor. That means the second value is completely dividing the first value. That is the case of our factors. That is the meaning of factor. And factor theorem states exactly that. Just remember, in remainder theorem, you will be provided with your g of x and you will be provided with your p of x. That means you will be presented with your divisor and dividend. But sometimes in a factor theorem, you might not be presented with what? Your divisors. You will be given your dividends, but you won't be given your divisors. So how you are going to treat with that one? So I'm going to jump with this question now. This is our main question here. Now we have to do what? They have given you the term that we have to factorize this one. Now you guys remember, factors can be achieved with various methods, right? Some methods are what? You're completing squares, your middle term splittings. Then you had your identities also that we are going to study today as well. So you guys see, there are various methods to factorize a given polynomial, but sometimes while you're dealing with your cubic polynomial, the only method that you can apply here is your factor theorem. So factor theorem states that you have to do what? You have to keep on assuming the value of x, and after some assumptions, you will be getting a finite value of x, and at that value, your entire p of x, that means in our case this one, it will become 0. And once you get that value, once you get the value of x at which your entire p of x is 0, Then you're going to do what? Let's say that value is n. You're going to do what? This is n here. You're going to put it on the other side along with your x. So you will be having something like this, x minus n, which is equal to what? 0. So if you trace back your remainder theorem, you guys will be getting this, that this should be our what? This should be our g of x, right? We always put our g of x against 0. So we will be getting our g of x, then we have to have our q of x, and we have to have our r of x. Since we are dealing with the case of factors, so we will not be having any remainder, we will only be having our quotients. So in short, we have to do what? These are the steps. Firstly, do what? Assume value, get p of x 0, put that value, let's say x equals to n, that is the value which gave you p of x 0. So x minus n will be divisor. Then we will do what? Divide p of x with our g of x. In our case, g of x will be x minus n. Then you will be having a quotient q of x. If that is factorizable, so you will be doing what? You will be factorizing that also. This is already in your linear form. If it is not, then you have to factorize this one also. So you will be doing what? You will be applying all the methods that you have studied up till now. Then you will be getting the factors of your cubic polynomial. So how we are going to do that one? Let's just look at this one. So if I erase this, so I have my p of x, which is what? It is x cube minus 23x square plus 142x minus 120. Now, if you remember anything from my previous class, I had told you that we always look for our constant value. So write down every possible factor of 120. It can be what? A positive and negative 1. It can be a positive and a negative 2. Since you have a negative 120, so either it can be a positive 1. If it has been positive 1, then 120 itself will be negative. Only then after being multiplied together, you will be getting a negative 120. So that's why I'm writing a positive or a negative 1. Their signs can alternate also. So positive and a negative 3, positive and a negative 4, positive and a negative 5, positive and a negative 6, positive and negative 8, positive and negative 10, positive and negative 12, and so on. So there can be many values here, even positive and negative 15 also. So you guys see there are various values. You have to do what? You have to start with the lowest one here. In our case, it is positive or negative 1. You have to do what? You have to replace your x with either a positive 1 or a negative 1. At any given value, once you end up getting a 0, that means that will be the factor of your, that will be one of the factors of your given polynomial. So I'm going to start with this one. I will be doing what? I will be assuming let x equals to 1. Replace in p of x. So if I replace it here, I have what? P of 1, which is equal to what? It is equal to x cube, sorry, not x cube, since we are replacing that one. So it should be 1 cube of 1 minus 23 into square of 1 plus 142 into 1 and minus 120, right? So cube of 1 is 1 and square of 1 is 1 also. 1 into 23, that will be negative 23. This will be positive 142 and ultimately this will be minus 120. Now guys see, positive and positive will add up, negative and negative will also add up. So I will be having what? A 143 and a negative 143. So our answer is what? It is 0. So now you guys see, at x equals to 1, p of x is what? It is 0. Therefore, x equals to 1 is a factor, or you can say, if I put it here, x minus 1 is a factor of p of x, right? So now I've got my g of x. My g of x is what? G of x is x minus 1. So I will be doing what? Now I will be actually performing my division in order to get my quotient. Remember, we don't have to think for a remainder because we are factorizing this and remainder automatically is 0. So don't go there. We have to find out the remaining factors of this equation, and they can only be achieved once we have divided our p of x with g of x, right? If we want to find out the remaining factors of 12, I can do what? Just divide 12 with 2, one of its factor. I will be having 6. So 12 into 6, that is what? That is, sorry, 2 into 6, that will be 12. Or you can say 2 into 2 into 3, that will be 12 as well. So you have various factors now, right? 4 will be a factor, 3 will be a factor, 2 will be a factor, 6 will be a factor, and 12 itself will be a factor. So there are various factors here. We have found those factors once we had divided our main polynomial or main value with our one of its factors, right? So I'm going to do what? I'm going to erase the remaining portion. Since we don't need them, I've got my remaining I have got one of the factors here. I just need to have the remaining factor. So I will be erasing this one. Let me just erase this real quick. Since it is x minus 1, I'm going to erase everything. One of the factors was x minus 1. Now we are going to do what? We are going to divide this polynomial x cube minus 23x square plus 142x minus 120. I have to divide this with x minus 1. Now division is very easy. You guys should be understanding this one. So x cube into x. If you compare these two, you need an x square. So x square minus x square into 1. That will be minus x square. This will be x cube here. X square into x cube, x square into minus 1, that will be minus x square. Now I have to do what? Just alternate their signs. This will be negative, this will be positive. This cancels out. 23 minus 1, that will be negative 22. Since 23 is negative and it is greater, so negative 22x square plus 142x minus 120. Now guys, see, I have x, I need x square, and I need negative 22. So I need a negative 22x. So that will be what? Negative 22x square, negative, negative, positive 22x, right? If I alternate their signs, this will be positive and this will be negative. This will cancel out. 142 minus 22, that will be 120x, and this will be minus 120. Now guys, see, I have x, I need a 120. So I will be adding 120 here. So this will be what? 120x minus 120. Alternating their signs, they will cancel out. My remainder is 0, which should be. So that means our p of x was the given statement, our g of x was one of the factors, x minus 1, and my q of x, that is what? That is x square minus 22x plus 120. Now we have to do what? We have to think of the factors that we can have here, and we have to factorize this equation. So I'm going to do what? I'm going to erase this portion here, since we do not need this. So I'm going to erase this. Give me a second. So as per the check formula, I know p of x will be equal to g of x into q of x plus r of x. Since remainder itself is 0, so that means p of x, it will be just equal to g of x into q of x. So I know my g of x is x minus 1. My q of x is what? It is x square minus 22x plus 120. Now I have to do what? I have to factorize this one. Factorization is totally up to you. Just factorize this here, x minus 1. Let's see what we have here. A 128 factor will be what? It will be 8 into 15. That can be one factor here, but their sum will be what? It will be 23, right? And let's see what else do we have. We have a 12 into 10, right? 12 into 10 is 120, and together they give you 22. So x square minus 12x minus 10x plus 120. Since we have to add these to have 22, and we have to multiply them to have 120. So we have the factors here, x minus 1. If I factorize this, taking x common, x minus 12. Taking a negative 10 common, x minus 12. So my factors are what? X minus 1, x minus 12, and x minus 10. So these are the factorized form of, these are the three factors of this cubic polynomial. So this is how you are going to factorize your given statement. How? Firstly, use your remainder theorem, and for that you have to assume each and every value of x. Keep on assuming till you get your p of x to be 0. Once you have found that value, once you have got your p of x 0, put that value against your x, get that g of x, divide your p of x with g of x, get that q of x. If q of x is factorizable, then you have to factorize that. Factorize each and everything, you will be getting the remaining factors that you need. So g of x will be one of the factors, and remaining factors will be given to you with this quotient. So you have to have that q of x. So I hope you guys understand this and you don't have any doubt in this case, right? So this is how you're going to attempt this one. I'm going to move forward with this. So we have these questions here. Determine which of the following polynomials has x plus 1 as factor. You have to do what? Just put that value here. Put x plus 1 against 0. Get that value of x, it will be negative 1. Put it in each case. Wherever you get a remainder 0, that means your final answer you get 0. That means that is the case, it will be a factor. So you can do this easily. You just have to put the values here, right? So put that x equals to negative 1 in each of these cases. Get that remainder. If that remainder is 0, then it is a factor. So you just have to simply apply your remainder theorem, right? Very easy. They use factor theorem to determine whether g of x is a factor of p of x in each of the following cases. So cases are these. This is your g of x, this is your p of x. You have to use your remainder theorem. Your factor theorem. Your factor theorem states that use remainder theorem and get the remainder. If that remainder is 0, then it is a factor. So simply we can do what? I'm going to do this one for you. We have p of x, which is what? X cube plus 3x square plus 3x plus 1, and we have our g of x, which is what? X plus 2, right? So put that g of x against 0, x will be -2. Replace it here. So p of -2, that will be what? -2 whole cube, 3 into -2 whole square, 3 into -2 plus 1, right? Then you have to do what? Just solve this one. Cube of -2, it will be -8. Square of -2 will be 4. 4 into 3, that will be 12, right? This will be a -6 and this will be a positive 1. So you guys see, adding these two, you will be having 13. Adding these two, you will be having -14. So -14 plus 13, that will be -1, which is not equal to 0. Therefore, g of x is not a factor. So this is how you're going to do these. I hope you don't have any doubt in these cases, right? So these are quite easy. So I hope you have already understood this one. So this is how you're going to attempt your remaining two questions as well. So you can easily do those as well. I hope you don't have any doubt here, right? Now I'm going to erase this one and let's see what do we have in the third part. We have this one. Find the value of k if x minus 1 is a factor of p of x. You have been given that x minus 1 is a factor of p of x. That means our g of x, x minus 1, if I put it against 0, I will be having x, which will be 1, and at x equals to 1, our p of x is what? Our p of x is 0, because it has been given to you that x minus 1 is what? X minus 1 is actually the factor of your p of x. So we will be doing what? Hello Raj. So it will be what? It will be this one. That means if I replace x at 1 here, our p of x will be 0. So I'm going to replace x with 1. So p of 1, it is what? It is, in our first case, let's assume this one, square of 1 plus k. Ultimately, it gives you a 0, right? That is the point here. So if I solve this, 1 plus k, that will be 0. 2 plus k, not 2k, 2 plus k, it will be 0. K will be what? -2. So value of k is what? It is -2. Similarly, you can find out the values here as well. Just put the value of x to be 1. Find out the value of k. Quite easy. You can easily solve them. I hope you guys will be able to solve them. So quite easy. Attempt these on your own. These are quite easy. Now I'm going to move forward with this. So we have these questions right here. We have to factorize them. Now listen to me when I tell you, they have just asked you to factorize them. So there is no point of even going with the factor theorem. Don't just look for the factors there. You can easily factorize using a middle term splitting method. I'm going to do these two for you, then remaining you can do on your own. So we have 6x square plus 5x minus 6. So firstly, let's find out AC. AC will be what? It will be -36. And then B is what? B is +5. While you're using the middle term splitting method, always observe for the sign with your constant value here. It is negative. So you have to write AC in such a way that subtraction of those two factors will be giving you a 5, and obviously multiplication of those two factors will be giving you a -36. Now I guess you guys should be able to guess this one. There will be 9 and 4. See, if I take 9 negative and 4 positive, positive and negative, negative, 9, sorry, we have to take 5 positive, right? So it will be alternate here since our B is positive. So we will be taking 4 negative, so 9 minus 4, that will be 5. 9 into -4, that will be -36. So I've got my factors here. So I'm going to do what? I'm going to erase this one. See, again I tell you, firstly find out your AC, find out your B, observe the sign that you have with your constant value. Whatever sign is present there, in our case we had what? We had this negative sign. This means we have to subtract. If there had been the positive sign here, that means we had to add. Keep in mind, this sign gives you the hint here. So we had to subtract. So you guys see, I had subtracted 9 and 4. We had got 5. Now this sign right here will be telling you what will be the sign with the biggest value or the largest value? In our case, we had the 9. We had 9 here. So this gave me a hint that our 9 has to be positive. Only then I can get my 5 positive. So I made my 9 positive and took my 4 negative. So my factors will be this: 6x square plus 9x minus 4x minus 6. See, this is the trick right here. This is not the traditional way. Guys will be telling you what you have to just divide the equation first with 6. Then you have to do what? You have to look for the constant value. Then you have to look for the factors of that constant value. That is the actual method, but that is quite lengthy. Nobody goes with that method. See, that is quite impossible to even think for that method. I will be telling you the easiest method. Nobody is going to ask you how you got these factors, but you should know that you have to find out AC, you have to find out B, then you have to look for the factors there. So that is the whole point. Put the bracket over here, put a bracket over here. Out of these two, I can see a 3x common. Taking that, I will be having a 2x plus 3. Out of these two, I firstly have to write the same portion here. So 2x plus 3. I can see I had 4x, I had only 2x here. So that means I had taken a 2. I had 6, I had a 3 here. That means I did have taken out a 2. Now I could see that my 4 was negative here, but 2 was positive. So that means I had taken a negative 2 common. So factors were what? 3x minus 2 and 2x plus 3. So these are the values here. I hope you guys will be able to understand this one, right? So this is how you're going to attempt for the factors, right? So you can do the remaining questions on your own. I don't have to go for that. Now the main question is here. I will be having this one. These are the cases that we had just completed in our factor theorem also while we were studying that. So remember, these are exactly going to be done with that method, although there are some questions here, like our first one. See, x cube minus 2x square minus x plus 2. This is quite easy. It can be solved regardless of your remainder theorem, or you can just do it orally here. See, out of these two, I can see an x square common, right? I will be left with what? X minus 2. And just write it here, x minus 2 as well. You guys see, I have an x here, I have x here. That was negative, that is positive here. I had a positive 2, I had a negative 2. So that means I have not taken anything common apart from a 1. So factors are what? X square minus 1 and x minus 2. So you guys see, we just factorized a cubic polynomial here, right? Now this is not actually factorized yet. You guys see, if you look at this one, this is x square minus 1. See, if you remember your identity a plus b into a minus b, what was that? It was a square minus b square. I can see an a square here, that means x square. Can I write 1 like this? Whole square. So this is what? A square minus b square. So this should be what? A plus b, that means x plus 1. A minus b, that means x minus 1 and x minus 2. So these are the three factors of a cubic polynomial. And you guys see, we did not even apply our remainder theorem. We could just easily solve this one orally. So remember, if you have the keen eye here, you can easily do that one. But that will not be applicable in this case. Will this be applicable in this one? Think of this. It surely be applicable in this one also. See, if I just erase this one and let's see whether it is applicable or not. 2y cube plus y square minus 2y minus 1. Put a bracket over here. Put a bracket over here again. So you guys see, out of these two, I can see a y square common, right? I will be left with a 2y plus 1 and write 2y plus 1 here as well. So I can see I have taken a negative sign common and I have taken a 1 common. So my factors are what? Y square minus 1 and 2y plus 1. So you guys see, again, this is what? Y square minus 1 square, a minus b, a square minus b square. So that should be what? A plus b, y plus 1, y minus 1, 2y plus 1. So you guys see, this is quite easy. Although if they have asked you to attempt this question and they have marked the question for 5 marks here, then you have to attempt it exactly like we have done in our earlier method in our example also. So you have to do it exactly like that. But if they haven't asked you to factorize, if they haven't provided you marks which are like 5, they have just asked you for 2 marks. So you guys should be automatically getting an idea that it is not quite lengthy one. We have to just look for this one. So you always have to have a keen eye in order to factorize even cubic polynomials also. They are easy to factorize if you have a keen eye. You guys see, these two were quite easy. We did not have to even think twice. Our factors were right in front of our eyes. So that is how you're going to attempt these, right? So I'm going to do what? These are quite easy. You can easily attempt any of these remaining two. So I'm going to move forward with this. So now we are come coming to our point here, algebraic identities. Most of these identities you guys already know. So algebraic identities are used in order to make our calculations easier while you're dealing with something like this. Let's say 110 into 110. Although this is quite easy, you can do it like this, 0, 0, right? Square of 11 into 100, right? That can be easy here. But let's say if they had asked you something like this, 89 into 100, let's say 11. Then how would you be solving this one? Here in such scenarios, algebraic expressions or algebraic identities come handy. See, can I write 89 like this? 100 minus 11, right? And can I write 11 like this? 111 like this, 100 plus 11. Now you guys see a minus b, a plus b, a square minus b square. So this will be what? Square of 100 minus square of 11. So you guys see, answer will be quite easy to calculate. So this is how you are going to use your algebraic identities in order to do your basic calculations, or you can just factorize some. So in some cases your polynomials will be given to you in their lowest forms, or let's say they will be given to you in their expanded identity form. Let's say if they have given you something like this, 2x plus 1 its whole square, they have given you something like this, 4x square plus 4x plus 1. See, if you guys go for this normal way, you guys will be thinking of what? You guys will be thinking of middle term splitting method. But if you guys know the basic identities here, this is what? This is a plus b's whole square. See, 2x whole square, 4x square, 1's whole square, 1, 2ab, 2 into 2x, that will be 4x. So identities also will come handy in such scenarios. So there are some common identities here. Every identity is based on this concept. You just have to remember the product of two linear equations. Sorry, two binomials. See, not linear or quadratic, two binomials. See, if you have something like this, x plus a into x plus b. If you guys remember how to multiply these two binomials here, that is quite easy. Put one term here, another here, put another bracket with that one, x plus b, multiply these two, x into x, x square, x into b, xb, a into x, ax, a into b, ab. So you guys see, this will be what? X square. Out of these two, I can take an x common, a plus bx plus ab. This is also an identity while you have something like this. And every other identity that you are going to get now from now on will be based on this common multiplication of two binomials, or even you will be having more than two binomials here. So that is the whole point here. So our first identity, this is a plus b's whole square. This is what? This is actually a plus b into a plus b. So you guys can easily multiply them and then you can solve them. So it will be what? It will be a square plus b square plus 2ab. These are the things that should be discussed with you in class 8th also. So you guys see, if we had a square and I can explain it to you that way, but I hope you guys already remember that, so I'm not going to waste the time here. Once we have completed this chapter, I might be having that session where I will be explaining you how you have got that one with your squares and everything, if you guys don't remember that from your class 8. So this is the whole identity here. If you have negative sign here, a minus b whole square, that will be what? A square plus b square minus 2ab. Or you can write them like this, a square plus 2ab plus b square, or a square minus 2ab plus b square. Then we have another identity which is a square minus b square. That is what? A plus b into a minus b. Or you can say a plus b into a minus b. That will be what? A square minus b square. Then we have another identity which is a plus b plus c, its whole square. That means square of a trinomial equation. So that will be what? A square plus b square plus c square plus 2 common ab plus bc plus ca. You can use this one also. You can use this a plus b plus c into a plus b plus c. Then you can easily prove this equation yourself. So this is the identity here. Then we move on to the cubic identities, and for that method, let's just pause it here. If we want to find out value of a square plus b square, then it can be this one, a plus b whole square minus 2ab. Just substitute negative 2ab here. If you want to find out the value of a square and b square, and you have been given a minus b, so it should be what? A square plus 2ab, right? If you want to find out a square plus b square plus c square, that will be what? A plus b plus c, its whole square minus 2 into ab plus bc plus c. That is the case here, right? If you want to find out these values. Now I'm going to do what? I'm going to jump towards the cubic identities here. So I'm going to erase this. So a plus b, its whole cube, that is what? A cube plus b cube plus 3ab into a plus b. You can do what? You can use this one, a plus b into a plus b into a plus b. Multiply these two, or you can do what? Let's see. I know it will be what? A plus b whole square into a plus b. I know a plus b's whole square will be what? A square plus b square plus 2ab. I have to multiply this with what? A plus b. Now I'm going to do what? A here, b here, put the remaining bracket here, a square plus b square plus 2ab, and here a square plus b square plus 2ab. So if I solve this, this will be what? A cube plus ab square plus 2a square b plus b a square b, multiplying these two, multiplying it here, that will be b cube, plus multiplying it here, it will be what? 2ab square. So you guys see, ab square, that will be 3ab square, 2a square b, that will be 3a square b, and you have what? A cube plus b cube plus this. So if I just do what? If I just multiply these two here, it will be what? 3a square b plus 3ab square. So you guys see, in short, this is the proof of your identity. So a plus b's whole cube is this one, and if I move forward, so a plus b's whole cube was a cube plus b cube plus 3ab into a plus b. So if you have b negative here, then this b here will be negative, this sign will be negative, and this ab will also be negative. Similarly, if you have a negative, then a cube will be negative, 3ab itself will be negative, and there will be minus a plus b. So that is the whole identity here. Now if I just write this one, we have one more identity here. This is a cube plus b cube plus c cube minus 3abc, that is equal to what? This will be a square. Sorry, if I erase this, firstly let's just start with the second one. If we want to find out the value of a cube plus b cube, that will be what? That will be a plus b. See, if there is positive sign here, so there should be positive sign here as well, into a square plus b square minus ab. That is the value of a cube minus b cube. If you want to find out the value of, sorry, a cube plus b cube, if you want to find out the value of a cube minus b cube, it will be what? A minus b into a square plus b square plus ab. So these are the identities here. Some of the identities are already mentioned in your books. I just have to write one more identity, then we are ready to go. So our last identity, it is this one, a cube plus b cube plus c cube minus 3abc. It is equal to what? A plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. Just do what? Solve this one, you will be getting this value. So that is the proof for your case. Now here I have some notations here, I have some proofs here. So if you have the sum of all three values, that means your a, b and c, together they add up to 0, then the value of a cube plus b cube plus c cube, that will be 3abc only. That means, let's say if I have something like this, if I have let's say 1x cube plus 4y cube, and let's say for, actually it should not be 4, let's say it is 8, and let's say I have what, a negative, that cannot be here, 2 and 3, let's say it is this one, negative 27z cube. Now guys, see, if I just write it, or write it in its lowest form, it will be what? X whole cube 2y whole cube and minus 3 z whole cube. Now guys, see, if I just use their variables same, let's just not take y, let's just take x here. So you guys see x here and x here as well. So you guys see, if you add them, 1 plus 2 and minus 3 all have x with them, together they will be adding up to 0. So its answer should only be what? Its answer should only be your 3abc. That is what I am trying to tell you. So this is the case here. I'm going to do what? I'm going to jump with our exercises now. Let's just start with this case. So we have to find out the products using identities. You guys see, this is x plus a into x plus a, or you can say a plus b into a plus b. This will be what? A plus b's whole square, which is what? A square plus b square plus 2ab. So solve this one, this will be what? X plus 3 whole square, this will be what? X square plus 9 plus 6x, right? Similarly, you can see here, this is like this, x minus a into x plus b, or you can say it can be like this, x plus minus a into x plus b. So you guys see x plus a into x plus b, that was what? X square plus a plus bx plus ab, right? So it should be what? X square plus, in place of a I have negative 3 and in place of b I have positive 5, x plus negative 3 into 5. So if you solve this, you will be having what? X square plus 2x minus 15. So these are the two answers of your example 16, right? Easy. Now let's move forward. So we have this one. Evaluate these without multiplying directly. We don't have to multiply them directly. So can I write it like this? See, 100 plus 5 for 105 and 100 plus 6 for 106. So if you just think of this for a second, put your 100 to be x. So you have what? X plus 5 and x plus 6. So this is like this, x plus a and into x plus b, right? This is of that identity, x plus a into x plus b. So it will be what? X square a plus b x plus ab. So this should be what? Square of 100 a plus bx, that means 5 plus 6 into 100 plus ab, 5 into 6. So this should be what? A 10,000, that will be 1100, and this will be what? A 30. So add them, you will be having what? 11130, right? So that is the whole point here. This is how you're going to do these. I hope you don't have any doubt in this, right? So quite easy. So let's see what do we have next. So we have to factorize them. Now you guys see, we have this one, 49 a square plus 70 ab plus 25 b square. Can I write 49 like this? 7a its whole square. Obviously I can, because square of 7 is 49 and square of a is a square. So 7a square. Can this be this? 5b square. And if I factorize 70ab, it can be this one. See, 7 into 10, or it can be this 7 into 2 into 5. Let's say 7 as a and 5 as a b. So this is what? 2a b, because our a is this one, b is this one. So this is what? 2 into 7a into 5b. So you guys see, a square plus b square plus 2ab, that is what? A plus b whole square. Easy, right? Now for the last one, you have this one, 25 by 4 x square minus y square by 9. This will be what? 5x by 2 its whole square, right? And y square by 9 can be written like this, y by 3 its whole square. Again it is like this, a square minus b square. So it should be what? A plus b, 5x by 2 plus y by 3 and 5x by 2 minus y by 3. So this is the factorized form, right? So you guys remember how we are using our identities in order to factorize the given statements. So this is how you are going to use your identities and factorize the statements. So let's move forward with this one. So we have to write this one in expanded form. Quite easy. This is a plus b plus c its whole square. You can easily solve this one. This will be a square plus b square plus c square plus 2ab bc and ca, right? You can easily solve this one. So let's move forward. Again we have to expand this one. Quite easy, like the one we have done earlier. Now we have to do what? We have to factorize this. So see, always remember we have three terms and each of them is carrying a square. So this should be like this, a plus b plus c its whole square. It has to be converted into this form. So you guys see, can I write 4x square like this, 2x its whole square? Can I write y like this, y is whole square? Can I write z like this, its whole square? And 4xy, this will be what? 2 into 2x into y, right? And can I write 2yz like this, 2 into y into z, and lastly 2 into 2x into z, right? Now you guys see, the only term which has x and z with it, it is positive. Both of these are negative. That means the term that they are sharing, which is common, it is y. So that means our y has to be negative. Only then I will be getting this negative value. So our factorized form is what? It is 2x minus y plus z its whole square. See, These two terms are negative, but the terms which are sharing only x and z, they are not negative. That means x and z itself are positive, but y is negative. So that's why we are getting negative 2xy and negative 2yz. So that is the whole point here. So this is what? This is the identity. Factorized form will be what? 2x minus y plus z into 2x minus y plus z. This is the factorized form, right? Quite easy sums. So you can easily solve them. You have to expand these cubes. You can do them. A plus b's whole cube, a minus b's whole cube, You can do this easily. Then you have to use this identities and evaluate them. See, you can write it like this: 100 plus 4 whole cube. Expand this one using a plus b's whole cube. Now you can write 999 like this: 1000 minus 1, its whole cube. See, it is better to write it like this rather than writing it like this. 990 plus 9. That will be quite lengthy. Try to use as close as to 100 or a multiple of 10. So that will be whole point here, right? Remember, this is also a multiple of 10, but what I mean with that is the complete multiples of 10 or the powers of 10. So you guys see 10, 100, 1000, then you will be having 10,000 and anything like that. So you're going to use those and solve them. I hope you don't have any doubt in this. So you have to factorize this, quite easy. This will be what? 2x's whole cube. This will be what? 3y's whole cube. This will be what? 3 into a is what? 2x, and b is what? It is 3y. 3 3s are x square y, right? So this will be, let's just do what? Take 3xy common out of this. So if I take 3xy common, I have what? I have this. This will be a 12x, and that will be what? Let's just wait. What we are going to do here, it is quite easy. You guys remember your identity a plus b's whole cube. It is what? A cube plus b cube plus 3ab into a plus b, or it is what? Or it is 3a square b plus 3ab square. So if I just pick this one and if I square this 2x, that should be what? 4x square, and y is what? It is 3y. So you guys see 3 into 3, 9, 9 into 4, 36. Similarly, this will be what? 3ab square. So that means 3 into 2x into 9y square. So this will be what? 27, 27 into 2, 54. So identity is what? 2x plus 3y whole cube. So this is the factorized form. Just write 2x plus 3y thrice, 2x plus 3y, 2x plus 3y, and 2x plus 3y. Easy. So you are going to attempt everything like this. So this is quite easy, like the one we have done earlier. Now you guys see, we have this one: 8x plus y, 8x cube plus y cube plus 27z cube, and this is 18xyz. So you guys remember, this is like this: a cube plus b cube plus c cube minus 3abc. Now in our case, we have three different variables, so its answer should be what? A plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. So you guys see, a will be what? It will be 2x. So you guys can easily solve this one. So this will be what? 2x plus y plus 3z into 2x square, that means 4x square, y square plus square of 3z, that will be 9z square, minus ab, 2x into y minus 2xy, to bc, y into 3z, that will be what? Sorry, yeah, bc, that will be what? Y into 3z, that will be 3yz, and ultimately it will be what? Minus 6zy. So this is the factorized form. I hope you guys will be able to attempt now every question that you can see. You just have to use the identities here. So summary for this chapter now, summary for this week, that means for this chapter, not week. So we have learned what are polynomials. We understood division of polynomials, right? We divided to p of x and g of x, right? Then we got a q of x and r of x. Then we understood a remainder theorem. It was what? In order to calculate only remainder, we used to do this: put g of x against 0, get that value of x, put it in our p of x. Whatever you get here, that will be what? That will be a remainder, right? Then we had a factor theorem. We used to do what? We used to have a remainder theorem. Once we have got the remainder 0, that means our g of x was factor of p of x. If we had a cubic polynomial, then we used to think of the values at which our p of x should be 0. Once we got that value, that will be acting as our g of x. I will be dividing p of x with g of x. Then we will be factorizing our q of x and everything related to that. So this is it, and we have just understood our identities also. That was quite recently, so you guys should be remembering your identities also. So in this chapter, towards the end of this chapter, we have understood everything that we had to understand regarding our polynomials, their division, their factorization. So these are the things that you should keep in mind. Remember your exercise 2.3 and your exercise 2.4. These are very important. You cannot skip these. I will be having a session tomorrow that will be based on the practice exercises. Based on this, we will be having some different questions there that are from the point of your examination, but are not included in this chapter in your NCERT. So I will be having those questions as well. Some concepts that I will be discussing in tomorrow's session. So do join that one also. Till then, practice each and every sum that you have up till now, that you have understood up till now, and make a proper note so that you don't forget anything. I'll see you tomorrow at the same time in the next session. That will be the final session for our chapter 2. Till then, practice as much as you can. I'll see you tomorrow. Bye.